Let's start with Mathematics Paper 1 of November 2021 to help you get ready for prelims and final examinations. The first question is solve for x, and we will solve for x and these four equations. In 1.1.1 we have x squared minus 2x minus 24 is equal to 0. So this is a simple factorization sum where we will factorize the trinomial. There are no coefficients in front of the x, so I can simply place the x in my two sets of brackets. Next, I'll focus on negative 24 to build the middle term of negative 2x. And what I mean by that is that I'll take the factors of 24, so that is 1 times 24, 2 times 12, 3 times 8, and 4 times 6. So all of these factors are the factors of 24. And I want to find a difference of 2 between the factors in order to create the middle term of negative 2x. So here I can see that 4 and 6 has a difference of 2. So I'll have 4 minus 6. So in my brackets I'll have plus 4 minus 6 as equal to 0. Then I simply need to set every bracket equal to 0 in order to find the values of x. In our next question, we have 2x squared minus 3x minus 3 equal to 0. And they give us a little hint. They say solve for x correct to 2 decimal places. This is an indication that you need to use the quadratic formula. And you can find the quadratic formula on the formula sheet of your examination paper. So in our equation, the coefficient of x squared would be our a value, negative 3 would be our b value, that is the coefficient of x, and negative 3 as the constant would be our c value. And I substitute these three values into my formula. So that will be x is equal to negative 3 plus minus, in a square root, we have negative 3 squared minus 4 times a, which is 2, times c, which is negative 3, over 2 times the a value of 2. Notice that I show my substitutions into the formula in terms of brackets. This will help me to recognize that I need to multiply out these terms. So you can use your calculator and enter in this equation, but you would need to enter plus and minus separately. So first, if I just use a plus, that will simplify to 3 plus the square root of 33 over 4. Then on your calculator, you press the SD button to convert between surd and decimal. And then you can find that x is equal to 2.19. In our second solution, I would substitute negative in the place of plus on the calculator. That will lead to an answer of 3 minus the square root of 33 over 4. And again, you press SD on the calculator to find the x value of negative 0.69. In 1.13, we have a quadratic inequality. First, what you need to notice is that there is a negative 4 isolated on the right-hand side. And what you want to do is move this negative 4 with all the terms in order to create a trinomial. So that will lead to x squared plus 5x plus 4 is smaller or equal to 0. Notice that when I move the 4, it turns from a negative 4 into a plus 4. Also notice that the direction of the inequality did not change by moving the 4. Now, in order for us to find the critical values, we again need to factorize this trinomial. So if I factorize, I have x and x in the brackets, plus 4 plus 1. Now I can find the critical values of this inequality. And we find the critical values by placing each of these brackets equal to 0. So my first bracket, x will be equal to negative 4. And in my second bracket, x will be equal to negative 1. Now this is normally where the confusion comes in. What I recommend is that you draw a number line and plot negative 4 and negative 1 on the number line. Notice that we are working with x squared. So if you remember the properties of a parabola, that will form a smiley graph. And these critical points would be the points through which the smiley graph moves. And we are looking for the values on the number line where this inequality would be smaller or equal to 0. So how you interpret this number line is that once you're above the number line, the values would be bigger or equal to 0. And when you are below the number line, the values would be smaller or equal to 0. And here we can see that between -4 and -1, the graph is below the number line. So in order to satisfy this inequality, x needs to be between -1 and -4. If the inequality was the other way around, meaning bigger or equal to 0, then we would need to be above the number line. So that is for the places where I'm highlighting in yellow, and we can see that x would then need to be bigger than -1 and smaller or equal to -4. 1.1.4. We want to solve for x, and now we have a square root involved. The procedure is pretty simple. In order to get rid of the square root, I simply square on both sides. So on the left-hand side, I'll have x plus 28, because a square root squared would remove the square root. And on the right-hand side, I'll have 4 minus 4x plus x squared. So when you multiply out a bracket squared, you don't just simply square the terms on the inside of the bracket. So it simply doesn't become 4 minus x squared. What you rather need to do is have 2 minus x multiplied with 2 minus x. And if you FOIL this out, meaning you multiply every term in the first bracket with the second bracket, then you'll end up with a trinomial. Now that is a common mistake that still takes place in examinations. Next, I'll rewrite this equation in standard form. So what I'll do is I'm going to move over the 28 and the x to the right-hand side, because I already have a plus x squared on the right-hand side. So that'll be x squared minus 4x, and moving the x over, minus x plus 4, and then moving the 28 over, minus 28 equal to 0. And when I simplify that, I have x squared minus 5x minus 24. Now again, I will factorize the trinomial, but you are welcome to use the quadratic formula. And yet again, we have 24. So the factors of 24 were 1 times 24, 2 times 12, 3 times 8, and 4 times 6. And I'm looking for the set of factors of 24 that will give me a difference of 5 between them. And we can see that 3 and 8 has a difference of 5. So my second term in each bracket would be 3 and 8. The 8 would be negative and the 3 would be positive, because we want to lead to a negative 5x. So we will give the larger number the minus sign. So x can potentially be -3 or x equal to 8. Now for this question, you need to remember to test your values. What I mean by testing is you take each of these values and substitute them back into the equation and see whether or not the left-hand side is equal to the right-hand side. So if I substitute x with 8, that will lead to 6 equal to -6. Now that is impossible. 6 cannot be equal to -6. So therefore x cannot be equal to 8. And if I substitute -3 in the place of x, that will lead to 5 equal to 5. So the left-hand side is equal to the right-hand side. Therefore x can be equal to -3. Our next question is to solve simultaneously for x and y. So here we have 2y is equal to 3 plus x, and 2xy plus 7 equal to x squared minus 4y squared. Now in an examination, what I always prefer to do is to rewrite the equations onto my answer sheet. Then I can see that the equation on the left, let's call that equation number 1, is simpler than the equation on the right, let's call that equation number 2. And I can easily manipulate this equation to find x alone on the one side. That means to make x the subject of the formula. So if I rewrite this equation, I see that I can easily substitute x in my second equation with 2y minus 3. So what that would look like is I'll have 2 times 2y minus 3 times y plus 7 equal to 2y minus 3 in brackets squared plus 4y squared. So notice that I've replaced x in my second equation with 2y minus 3. So now I have an equation with only one variable, and by multiplying out the brackets, I can easily solve for y. Notice that when I substitute it, I have 2, and then I had brackets, and then a sneaky little y behind the brackets. And what I did now is I rewrote this as 2y, moving that y at the back to the front. This will help me to multiply out a bit easier. So now if I multiply out, I have 2y times 2y, which is 4y squared. 2y times 3y is negative 6y plus 7 equal to 2y minus 3 times 2y minus 3 plus 4y squared. Now I'm rewriting it like this in order to avoid the mistake of simply saying 4y squared minus 9. So if I multiply out on the right, I have 4y squared minus 12y plus 9 plus 4y squared. So 2y minus 3 squared is expanded into two brackets, and when I multiply out by foiling, I have 4y squared minus 12y plus 9. Also notice that I have 4y squared plus 4y squared on the right hand side. So when you add up those like terms, you have 8y squared. And again, I'll move everything over to the right hand side in order to simplify. So I have 8y squared minus 4y squared, and that is equals to 4y squared. Then negative 12y plus 6y, that is equals to negative 6y. And lastly, plus 9 minus 7, which is equals to plus 2. Notice that all of the coefficients are even numbers, so I can divide everywhere by 2 in order to simplify this equation. So that will be 0 is equals to 2y squared minus 3y plus 1. And now if I factorize, I have 2y in my first bracket, y in my second bracket, and 1 as my constant second term in each bracket. Also, the signs would both be negative because I need to create a middle term of negative 3y. Therefore, y is equals to a half, or y is equals to plus 1. So now I have two values of y, and I'll substitute these two values in my equation of x in order to find values for x. So x is equal to 2 times y minus 3. So when y is equals to a half, x would be equal to negative 2. And x equals to 2 times 1 minus 3. So that means that when y is 1, x is equal to negative 1. The next question is a little bit of a curveball. It is an awkward one because it's not one that we see often. So what I'll do in the exam is I'll leave space open in my answer booklet and come back to it later. So let's read this question. The roots of an equation are x equal to this expression, where m, n, and p are positive real numbers. The numbers m, n, and p in that order form a geometric sequence. Prove that x is a non-real number. So for x to be a non-real number, the square root in our equation must be negative, because when the square root has a negative value on the inside of it, then that square root cannot exist, and that's what we call a non-real number. So from the information given to us, we want to see that n squared minus 4mp is smaller than 0. But if we look carefully at this equation, we see that it looks quite similar to the quadratic formula. And also, when we discuss the nature of roots, we discuss delta, where delta is equals to b squared minus 4ac. So if delta is the contents of the square root, then n squared minus 4p must be delta. Next we have m, n, and p are positive real numbers, and the numbers in that order form a geometric sequence. So that means we have a number pattern of m, n, p, and it's a geometric sequence. So it has a constant ratio between terms. Now, in order to find the ratio in terms of m and n, we'll take the second term divided by the first term, and that is equals to the third term divided by the second term. So now I have n over m is equals to p over n. And if I cross multiply, I have n squared is equals to mp. So now again, I would look at the contents of the square root, and I see that I have 4mp, and I can replace that 4mp with n squared. So I'll have n squared minus 4 times n squared. And if I simplify that, I have negative 3n squared. And we know that n squared would always be bigger than 0, because any value that I square would give us a positive answer. Therefore, negative 3 times n squared would always change to a negative answer, meaning smaller than 0. And now we have proven that delta is smaller than 0. And when delta is smaller than 0, we can say x is a non-real number.